Okay, solving a quadratic equation is a big thing that we need to review. Everybody needs to remember the various methods to do that. The two key methods are listed here. The first one being using the zero product property. We're going to go over that in a moment. And the second one being the quadratic formula. And you need to have that memorized. So there's many songs out there to memorize this thing. There's the Pop Goes the Weasel version. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There's the Jingle Bells. X equals negative b plus or minus radical b squared minus 4ac all over 2a. And then there's kind of the swing version. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. So whatever sticks in your head, listen to it over and over again and get it memorized. So let's actually see these in action. So we're going to use, first of all, the zero product property to solve this equation here. This one's an easy one. Fortunately, there is a 1 as a coefficient, so it makes it more easily factorable. It's going to factor into two sets of parentheses, two things times each other that equal 0, two factors. And a nice little graphic organizer to organize this is to, a lot of people call it a diamond problem, because if you draw all of it like this, the diamond shape, you typically take the last number times the first number, which in this case is 1, and place it in the top box, and the middle number, the b value, and place that in the bottom. So we're looking for something that multiplies together to make negative 10 and adds together to make a negative 3. So I know that 2 times 5 makes 10, and if I make that 5 negative, it all works out beautifully. So if the coefficient is 1, we can go directly from here, and we've got an x plus 2 as one of the factors and an x minus 5 as the other factor. Now that was the factoring part. That's what you do first in using the zero product property. This right now is actually the zero product property part. That property says that anytime you have two things multiplied together, or even a string of many things multiplied together and they equal 0, it means that either one of those or the other has to be 0. One of the terms must be 0 to make that happen, to make that true. So we see what happens in each case. So if this factor is the one that's 0, what would the x have to be? Well, we could solve really easily by subtracting 2 from both sides. And we can, in our head, probably even before that, know that a negative 2 would make that 0. So there's the first solution. And the second solution comes from this one. Well, what if this was the factor that was equal to 0? If this was the factor that was equal to 0, it would look like this, and x, to make that true, would be 5. So the solution is negative 2 or positive 5. Now let's take a look at the quadratic formula. Here's the formula. First off, you need to remember that we need to put the equation in standard form. This one is. Standard form has your squared term first, your x term in the middle, and constant at the end. And there's an a term, a b term, and a c term that come directly from the coefficients in each of these cases. So there's a hidden 1 right there, an understood 1. So a is 1, b is negative 3, the coefficient, it keeps its sign, and c is negative 10. So to use the quadratic formula to solve this, we say that x is equal to the opposite of b. That's actually a really good way to think of this. It makes it easier. Opposite. So the opposite of b would be positive 3. Then we do either plus or minus square root of b squared. Well, it's negative 3. Negative 3 squared is 9. Minus 4, there's always a 4, times the a, 1 times the c, negative 10, divided by 2 times a, which is 1. Okay, so then we simplify that. In the next step, carry down this and this. This ends up being 9 minus a negative 40, which is a positive 49, divided by 2. And this equals, this plus or minus thing is just to save some writing. We're going to go through this one time with it being positive. So it means 3 plus, since we know that square root of 49 is 7. So 3 plus 7 divided by 2, or 3 minus 7 divided by 2. And so therefore this is x equals 5, or x equals negative 2. And we got the same answer, did we not? Let's see. 5 and negative 2, 5 and negative 2, yes. Okay. Now, in class tomorrow, we're going to be doing this section 1.4 or 1.1.4. How can I represent intersections? Okay, intersections are places where you do two equations and graph two graphs on the same set of axes and they intersect in a place. Let's say I do a positively sloped line and a negatively sloped line. Here is their intersection point, and they have an xy, that point has an xy value, which could be one of the solutions to that system of those two equations. So we're going to be looking at the points of intersection, two graphs in one, and we're also going to look at multiple representations. This is our multiple representations graph. There's 4 main representations of any kind of math situation. There's a table of the information, the inputs and outputs, a graph that models that, an equation, and the situation that it belongs to. Sometimes you only know a couple of them, and usually it's the top 3. Sometimes the situation is it's just a made-up equation for us to work on in math class. So we're going to be working on this problem here, intersection investigation, and primarily in class it's going to be done on our graphing calculator. As you see, there's a graphing calculator symbol here, and it says about we used various features of the graphing calculator to find a point of intersection between two graphs. And we're going to see if we can use other representations as well. What about other strategies? Are the strategies all accurate, and which do you prefer? So right now with this video, we're going to start this problem, but we're going to look at the strategies that do not go with the graphing calculator right now, so we can use the graphing calculator in class tomorrow. So let's take a look at, this is still the same problem, the task. Work with your team to find as many ways as you can, with and without your graphing calculator, to determine the points of intersection of these two functions. Be sure to think about tables, graphs, and equations as you work. Those 3 representations. We're going to look at tables and graphs tomorrow because those can be done with the graphing calculator. Right now, let's take a look at what we can find out from the equations. Okay, these are both quadratics, and a place where we can find an intersection is a place where they equal each other. So we can set them equal to each other to solve. So the algebraic method would be to copy down f of x, the first function, as such, and set it equal to g of x, the second function. Now I'm seeing that this is a quadratic equation. There's an equal sign, and quadratic refers to the power of 2, and that's the highest exponent. So I've got 2 options to solve this. I can either factor it and use the zero product property, or I can use the quadratic formula. either way, I need to put this in standard form such that all the terms are on one side and it all equals 0. So I'm going to start by adding 2x squared to both sides. I'm also going to add 1x to each side because I'm trying to make all of this equal 0. This will be 0, this makes 0, and this makes, I need a minus 30 to make 0. And so minus 30 from here. So the result would be, I've got 4x squared, a negative 5 with a positive 1, minus 4x, and a 6, and a negative 30, negative 24. And it all equals 0. Ooh, I also noticed that there happens to be a factor of 4 in all of the terms. So I can make this problem even one step easier by factoring out 4. And that would leave me with x squared minus 1x minus 6 equals 0. If I divide both sides by that 4 that I factored out, that leaves 1. And 0 divided by 4 is just 0. So now we can factor this. And it factors into a 2 times 3, which makes them 6. One of them needs to be negative. The larger of the two needs to be negative to add together to make this negative 1. According to the zero product property, either this factor is 0, so x is equal to negative 2, or this one is equal to 0. So those are the two possibilities for x. Now when we're finding a complete solution, that solution is made of two coordinates, an x and a y. So we need to go back and find the x and the y for each of these. So what we do is take the first x and substitute it back in and solve for y, and take the second x and substitute it back in and solve for y. So let's go ahead and do that real quick. You can choose either of the two functions, whichever one you seem to like best. I'm going to go ahead and go for this one. So if I've got negative 2, plug in the negative 2 and square it, minus a negative 2 plus 30. So this makes positive 4 times negative 2 makes that negative 8, minus a minus, plus 2, plus 30. So the y value for this point is the sum of these, which is 24. And we can repeat that. It doesn't matter, again, which one we use. I'm going to go ahead and use the same one. So negative 2 times 3 squared minus 3 plus 30. Simplify this, we get 9 times the negative 2, negative 18 minus 3 plus 30, and our result is 9. So when we put the pairs together, we've got two ordered pairs, 2 points, 2 places where these curves intersect. Because the graphs are going to look something like this. It's an upside down parabola and a right side up parabola, and therefore there are 2 places that have an intersection point. One of them negative 2, 24, and the other one is at 3, 9. And we will verify that tomorrow with graphing calculators. That's it. Don't forget to do your homework problems that are numbers from chapter 1, numbers 12 through 18, and numbers 34 through 36 due tomorrow.